My topic is the predator-prey model and wildlife management. So what is the predator-prey model? It's an equation based on per capita growth rates of two populations used by scientists to determine relationships between predator and prey populations. It's also referred to as the Lotka-Volterra predation model. It's arguably the most straightforward model to depict interactions between predators and prey. There can be many different versions of this model, but the basic model just looks at interactions between a single predator population and a single prey population. Other variations may include more than one predator feeding on the same prey, or more than one prey being eaten by the same predator. So some background information on the scientists. We had Alfred Lotka, born in Lemberg. He moved to the US in 1902. And we have Vito Volterra, born in Italy. For this model of predation, both scientists were responsible for describing different aspects of the model. Lotka focused more on describing chemical reactions, and Volterra described the population interactions. Lotka was the one to propose the first model depicting these interactions between predator and prey, and Volterra was the one to assume that these population densities would have an effect on interactions. Why is it important? So it allows us to comprehend what factors can have an impact on a population. It can be used to determine what traits in one species can have an impact on the other, and to determine the interaction between different species in a community. It allows scientists to predict the result of an interaction between a predator population and a prey population, as well as finding effective ways to manage populations in different ecosystems. It allows us to comprehend the structure of a community and to observe and comprehend the maintenance of a community structure. So when you look at it graphically, we can see that they have an inverse relationship between predator and prey. When a predator population is absent from an ecosystem, the prey population rises exponentially. And when the absence of prey occurs, the predator population will fade out exponentially. Does it have limitations or assumptions? The answer is yes. A limitation is that it oversimplifies the conditions in an ecosystem, and assumptions include that the population is either stable or constantly changing. The population of prey grows out of control if there are no predators. Predator populations only feed on this one prey, so if it's absent, they'll starve. Predators can eat large amounts of prey without getting full, and the environment is not complex and therefore plays no role in these interactions. Hiroki Kuroda and his colleagues, they looked at interactions between kokanee and rainbow trout in Kootenay Lake in British Columbia. Their goal was to evaluate the interactions between predator and prey and establish an effective way to manage the recreational fishery events of the lake. They created two models, one excluding the interactions between these fish and one including these interactions. They then took the results and compared them to determine how prey can be affected by predator mortality and how the abundance of prey can impact mortality rates in predator populations. For kokanee, they assumed that the death of predators occurred after factors like fishing and their own death. And for the rainbow trout, they assumed that in the absence or when kokanee are low in numbers, they would switch their prey and experience reductions in body mass. So what did they find? Their models represented that the trout posing a predative threat on the kokanee was more likely than these two species not having any interaction. They were also able to use their data and results to determine some historical data about the ecosystem present in the lake. They found that at lower densities of prey, there seems to be more physiological stress on predators, increasing death rates and causing predators to be more risky when capturing prey. Their results help to support the theory that it is important to maintain high population densities of prey in order for predator populations to be able to survive. What happens when you remove predators? When predator populations increase, there's increased pressure on the prey populations, causing their numbers to decrease faster. Some scientists have experimented with the idea of removing predators from ecosystems to help maintain prey populations. Studies show that by suppressing predators, you can allow prey to reach their maximum abundance. Although removing predators can be effective to manage prey, they will still be impacted by environmental or demographic changes. Peter Baxter, he experimented. So they used the predator-prey model to see how effective controlling predator populations could be for conserving populations of prey. They had 5 strategies for removing their predators: immediate eradication, removing at a constant number, removing constant portions, removing those that didn't fit the threshold, and removing those whose offspring wouldn't fit the threshold. They found that the most successful strategy was immediate eradication. The next most effective strategy was the removal of constant number of predators and then removing predators who didn't fit the threshold. They found that the worst way to control prey populations was to constantly remove a certain number of predators